this is another one that people were not happy about. So let's do it together. So we want to take the derivative of this mess. So you would just take the derivative of that mess times the derivative of whatever's inside. Okay? If this were u, and u is a function of x, and the derivative with respect to x, it's an x derivative, it would be f prime of u times du dx. And what does that mean? That means you would take the derivative with respect to the native variable, but then take the derivative of that variable with respect to x. That's what that's saying. Okay, so let's, you could hear my scratching. Okay, so now what do? Well, we get rid of the x cubed. And this problem is, you know, too easy, right? Because the derivative of x to the fourth is 7 over 4. That means, look, it means that the x didn't matter. The x input wasn't used at all. Okay? So, all right, let's try a different problem. Let's say I'm going to make one up. Hopefully this will work. 12x is equal to 5x cubed. Okay? So again, I'm going to take the derivative times the derivative of what's inside. Hi, Theodore. If f prime of 12x is 5x cubed over 12, well, let's think about this. Y is equal to 12x. Then you solve, right? Y over 12 is actually x. So the inverse function is the divide by 12, right? So you can put in here, instead of x, for example, let t equal 1 over, let x equal t over 12, for example. Hey, he's very exuberant. T over 12 cubed over 12. And that means f prime of t, sorry about that, is equal to 5t cubed over 144, right? Because they're going to go 12 squared. Whoops. It's 12 squared. Whoops. Okay, it's going to look like that. What a pain. Okay. Let me just take this piece over here. Okay, I think we should do another one. Don't you? Yeah, if you don't want to do another one, then don't. Okay? I know, you're still here. Okay, let's make one up. F of 3x cubed equals 2x. I have no idea what it's going to do. Why don't we use sine and cosine? Well, because this is modeled after that question that we saw in web work. And this was the structure. It was always a constant over here, and some exponent on the x. So that was the structure of the problem that we are trying to mimic. So there's no profound reason why we don't use other things. But your exam will not have any other structure. It would just have like a coefficient here, and some exponent here and here. Those are the rules. Rules of the game. That's what we're doing. Okay. So same thing we did before. Take the derivative of the stuff times 3 times 3 is 9x squared. So that's the derivative of what's inside. and then we get rid of x on both sides. So we get rid of x, we're going to end up with divide by x, and it's going to look like that. So hopefully that part isn't tricky. Now, the next thing you want to do is you want to find the inverse of that 3x cubed. You can either say x is first cubed, then multiply by 3. To reverse it, we're going to divide by 3 and then take the cube root. Alright, but you could just formally do this thing where you just say y is equal to 3x cubed, and then you say what do you do to both sides, and hey, can't do that, he's bouncing all over me. There we go, and that's the inverse function. Okay, so you just put the inverse function back in for x, and that will undo the function, right? So you don't even have to write it if you don't want. You can just leave it like that. I don't really care. I mean, if you want to fix it, you can. I mean, there's a lot of simplification you can do, but you don't have to. The important thing is that you know the process. And yeah, I don't care if at the end you want to call this the letter T. It doesn't matter, right? It doesn't matter. If you prefer to use different letters as you're doing this, I don't care. But the important thing is that you find f prime with respect to a single variable. Okay?